Hey guys, I did my project on the neurological and biological effects of burnout. So, first, we must identify what burnout is. And according to the World Health Organization, burnout is seen as an occupational phenomenon rather than a mental disorder. And burnout is defined as the state of emotional, physical, and mental exhaustion caused by prolonged or excessive stress. According to the research I found, there were two main research methods. One of them we did not discuss in class, but was primarily used to support this research. The real time fMRI neurofeedback is like an fMRI but shows the direct feedback of the brain activity rather than having to wait on results. This method showed that certain circuits were wired towards the limbic alarm structures and away from the executive oversight structures. The other research method was the fMRI, which people are more familiar with, and the results in the imaging showed that people with occupational burnout are less likely to regulate negative emotions, and this is associated with the changes in the amygdala, which is the brain's emotional processing center. And there is a decrease in functional connection between the amygdala and the ACC, which is critical for emotional control. The three types of analysis that I decided to do for burnout are neurochemical, neuroanatomical, and genetic. The neurochemical change that burnout causes affects the HPA axis. This process is very familiar to what we have learned in class with the body's response to stress. This process starts with the activation of the hypothalamus. During stress, the hypothalamus releases the CRH. And then the CRH is sent to the pituitary gland and stimulates the release of the ACTH, which then travels to the adrenal cortex, prompting the release of glucocorticoids like cortisol. And then the result of this process causes individuals with burnout to exhibit an HPA axis imbalance and elevated cortisol levels, which indicate chronic stress. Due to the chronic stress levels neurochemically, the neuroanatomical impact involves reshaping of the amygdala. Chronic/long-term stress can cause retraction in certain areas in the amygdala and cause a shift in synaptic imbalance. The third level of analysis is genetic influences. A study was done on a group of nurses by exposing them to environmental stressors to see the level of methylation on the serotonin transporter gene, the results of the study showed that the decreased methylation of the gene was congruent with the levels of emotional stress. This graph shows that the higher the stress level, the lower chance of the methylation of the gene. In conclusion, burnout involves detectable changes in brain activity as shown in fMRI studies. Structural changes in the amygdala reveal neuroanatomical impacts of chronic stress. Neurochemical imbalances, specifically elevated cortisol, signify HPA axis dysfunction, and epigenetic modifications at the genetic level are highlighted by the methylation of the serotonin transporter gene. Thank you for listening.